The question says the treatment of alkyl chlorides with aqueous potassium hydroxide leads to the formation of alcohols. Let me write the chemical reaction. It says that when alkyl chloride, let's say we have CH3, it is CH2 and this is CLE there, alkyl chloride. And when it is treated with potassium hydroxide, aqueous medium is there. So alcohol is formed. We get CH3, it is CH2 and this is what OH we have. Okay, next it says, but in the presence of alcoholic KOH, alkene are the major product. When alkyl chloride, when the same alkyl halide is treated with potassium hydroxide in alcoholic medium, then alkene formation is taking place. Let's say we have CH3 and it is CH2 and the Cl is there, and here we have KOH and it is alcoholic medium. In this case, we get alkene, CH2 double bond CH2 is there. And this is what we have to explain why it is so. You can see reactant is same, KOH is also same, but medium is different. When the medium is different, the product is different. We understand very carefully, okay, how it occurs. Keep in mind, whenever potassium hydroxide is participating in the reaction in the aqueous medium, it causes nucleophilic substitution reaction. You can see it will liberate a nucleophile OH minus ion, strong nucleophile, and it will kick the weak nucleophile and complete the reaction. Displace the weak nucleophile. Okay, so you can see Cl minus ion is a weak nucleophile in comparison to OH minus ion. Okay, so in place of Cl, OH will come and reaction is completed. But when we have potassium hydroxide in alcoholic medium, it causes elimination reaction. In elimination reaction, how we complete? From alpha carbon we remove Cl, from beta carbon we remove hydrogen. Okay, so in this case what happens exactly? Let's say if it is CH2 and it is H is there, alpha carbon, this is alpha carbon, this is beta carbon. From alpha carbon Cl, from beta carbon hydrogen. HCl is removed. From here HCl. That's why this reaction is also known as a dehydrohalogenation reaction. Dehydrohalogenation, removal of hydrogen halide. Okay, removal of acid also we can say. This is acid, no? Removal of acid. Okay, so in this elimination reaction, acid is removed. What kind of acid? Hydrogen halide. And in this place you can see double bond will come to satisfy the valency of carbon. That's why we are getting CH2 double bond CH2. Now we understand why and how it happens exactly. So first I take a KOH aqueous. Okay, in this example we learn, KOH aqueous is there. KOH aqueous causes substitution reaction, nucleophilic substitution reaction. KOH is a strong base, we know it very well, and when KOH is added to water, it will dissociate into ions very easily. It can dissociate and produce OH minus ion. But problem with this is, you can see aqueous medium is there, so you can see OH minus ion is surrounded by water molecule. It is surrounded by water molecule. Okay, it gets hydrated is there. So tendency, you can see tendency to behave as having the basic character, it decreases. Its basic nature being hydrated decreases. Okay, hence it acts as a better nucleophile, because oxygen also having lone pair. Here it has negative charge, it can donate electron density in bulk. So this is the reason potassium hydroxide strong base is there. But in the aqueous medium, you can see OH minus ion being hydrated, its basic character decreases, hence it acts as a nucleophile. Okay, OH minus ion is liberated, it will kick the weak nucleophile, occupy the space of weak nucleophile and complete the chemical reaction. Okay, so always keep in mind KOH aqueous is there, it causes nucleophilic substitution reaction. But in case of KOH alcoholic, so what happens exactly when we have KOH alcoholic? Pay attention carefully. We have KOH and it is what? Alcoholic. Okay, alcoholic is nothing but we have C2H5OH there. Okay, if they are reacting, so in this case what happens? We have C2H5 and it is OH is there, we have KOH is there, so we can remove. In this case, remove water molecule is there. We remove water molecule. This is OH and this is OH is there. Here we get C2H5 and it is O, and this is what K is there. From here, this is negative, this is positive. We can see we get the strong base. this is a strong base is there, a strong base. This is weak acid, and this is what strong conjugate base of this weak acid. Okay, after liberating H plus ion, it is converting into this form. So it is acting as a strong conjugate base, and since it is a strong conjugate base, it will be targeting acid somewhere present in the alkyl halide. Okay, so you can see that's why it causes dehydrohalogenation, means removal of HCl, yeah, HBr, Hi. Okay, these all are acids. So since it is a base and it targets acid, that's why it causes elimination reaction. It causes dehydrohalogenation reaction, and that's why you can see in this case, since it is a strong base, you can see from here we are getting strong base. What we are getting, C2H5, it is O minus is there, strong base is there, strong conjugate base. We can write this is what is strong and conjugate base is there. So it targets, you can see, acid. Here we have H is there. Sorry, we have H is there. This is H is there, and in this case Cl is there. You can see from alpha carbon Cl, from beta carbon hydrogen is removed. This is what acid. Acid base, sorry, why that? This is base. Acid base reaction. It targets acid present in alkyl halide and causes elimination reaction. The place we remove HCl, yeah, hydrogen halide, that place double bond will generate, pi bond will come. Okay, so always keep in mind, if we have KOH aqueous, okay, if we have KOH aqueous, to keep in mind it causes nucleophilic substitution reaction, and if we have alcoholic KOH, since it produces strong base C2H5 and it is O minus is there, it causes elimination reaction. Okay, elimination reaction. If you like this video, please share and subscribe to the channel.